Welcome to my lecture on comparing means t-test. There are two ways to compare the means. One is t-test and the other is ANOVA. T-test is for comparing for two groups and ANOVA is for comparing more than two groups. What is t-test? T-test is a test of comparing two sample means. There are two types of t-tests: independent sample t-test and dependent sample t-test. Independent sample t-test is used when two groups of participants are assigned to different experimental conditions or when they belong to two different groups, such as sex. Dependent sample t-test is used when a single group of participants take part in two different experimental conditions or go through two testing conditions such as pre-test and post-test. Now let's talk about the rationale for t-test. Maybe you have heard that every test analysis requires a null hypothesis. The null hypothesis assumes that there is no difference between two sample means drawn from two groups or two conditions. In other words, there is no effect of independent variable on dependent variable. Most of the time, you want to reject the null hypothesis because you want to show with your data that the two sample means are different and there is an effect of your independent variable on dependent variable. So how do we know whether to accept or reject the null hypothesis based on running a t-test? Well, what t-test does is to calculate a t-value, which tells you whether your hypothetical model is good or not by feeding it to your data. If your hypothetical model is good, you reject the null hypothesis and conclude that there is a significant effect of your independent variable on your dependent variable. To calculate the t-value, there are two pieces of information you need from your data. One is explained variability and the other is unexplained variability. Explained variability is how much your independent variable explains your dependent variable. This indicates how good the model is or the effect. Unexplained variability is how much you cannot explain your dependent variable by your independent variable alone. This indicates how bad the model is. In other words, the error. To evaluate your hypothetical model, a t-test compares how good the model is against how bad the model is. But what exactly is explained and unexplained variability? Let me take an example and clarify this. Imagine that I give this whole cake to each of you. My dependent variable is the amount of cake you will eat when I give this to you, and my independent variable is whether you are a sugar freak or not. I hypothesize that those of you who are a sugar freak will eat significantly more amount of cake than those of you who are not a sugar freak. But whether you are a sugar freak or not may not be the only factor which will explain your cake eating behavior. For example, maybe there is a sugar freak who will still not eat cake because she's on a diet and she knows how evil cakes are when it comes to losing weight. Or maybe there is a non-sugar freak who would still eat the whole cake because she's so frustrated about learning statistics and she will put everything in her mouth right now to make herself feel less miserable. The thing is, you guys are so unpredictable that it is impossible for me to build a hypothetical model which will explain 100% of your behavior for every one of you. So, some part of your cake eating behavior will be explained by my hypothetical model, but other parts will not be. That's the explained and unexplained variability in dependent variable. When you run a t-test, your goal is to get an effect as big as possible and an error as small as possible. This will give you a t-value as large as possible, which will ensure you that your model is good to go. But how big does a t-value have to be to tell you that your model is good enough? That's when the magic p-value comes in, which I'm sure you all must have heard of. Basically, p-value can tell you whether your t-value is big enough to say that your model is good enough. So you can say that p-value is like an insurance for the t-value to tell you if your t-value is doing a good job. Statistically speaking, a p-value or significance value is a probability of getting a t-value as high as the obtained t-value by chance. What does that mean anyway? That means if this probability is less than 5%, you try to run the t-test 100 times, and there's only less than 5 times that t-value makes a mistake and don't get the value as high as it's supposed to be. So you can think of a p-value as the number of times a t-value makes a mistake. So the larger the t-value, the smaller the p-value. Because if a t-value is large, that means the t-value is doing a good job. So the p-value only needs to catch a t-value a few times for making a mistake. I hope this metaphor somehow makes sense to you. Now the bottom line is that you want the p-value to be less than 0.05 because this will allow you to reject the null hypothesis and conclude that your independent variable has a significant effect on your dependent variable. By the way, have you ever wondered why is p-value 0.05 and not 0.03 or 0.07? Well, the answer is as simple and as stupid as this. Because once upon a time, there was a guy called Ronald Fisher who said it should be 0.05, but not more or less. Many statisticians said this is ridiculous and this needs to change. They said, technically, every model is different, and every model needs its own unique p-value to be calculated, which totally makes sense. So far, not many educational researchers do something about it, because let's just say educational researchers are not the best when it comes to statistics. So it is much easier for them to listen to a stranger called Fisher and deal with just one number, 0.05, than listening to a guy called a statistician and calculating a new number every time they run a model. Okay, enough of talking about t-value and p-value. Now let's learn how to run an independent t-test using R. We will take the example of e-learning program. This is a quasi-experimental study where two groups of participants are placed either in an e-learning condition or a control condition. The outcome variable is participants' computer skills. We want to use the independent t-test to test whether the experimental group and the control group differ in their computer skills in the pre-test and the post-test. We would expect that the experimental group would have higher computer skills in a post-test compared to the control group because they go through the intervention, which is the e-learning program to improve their computer skills. This is how the t-value is calculated in an independent sample t-test. Explained variability is calculated by differences in computer test scores between two sample means, namely the mean from the e-learning group or the experimental group and the mean from the control group. Unexplained variability is calculated by standard error of differences between those two sample means. Now, let me show you how to run an independent sample t-test in R and R Commander. Here is the data that I created. In this data, there are 30 participants. Half the participants went through the intervention of e-learning program to improve their computer skills. The other half didn't go through the e-learning program, so this is a control group. They have pre-test scores and post-test scores. Now, I want to run an independent sample t-test to see whether these two groups differ in their scores on pre-test and the post-test. To run an independent sample t-test in R Commander, you can go to Statistics, go to Means, and click Independent Sample t-test. For a grouping variable, you can pick the condition, and for a dependent variable, I'm going to pick a pre-test scores. Click OK. And there you find the results for the t-test. You will get a mean for the e-learning group and no e-learning group. As you can see, descriptively speaking, the e-learning group has a slightly higher mean score than the non-e-learning group. To see whether these two sample means are significantly different from each other, you can check the t-value and the p-value. When the p-value is smaller than 0.05, that means these two sample means are significantly different from each other. When this p-value is bigger than 0.05, that means these two sample means are not significantly different from each other. In this case, I have a p-value of 0.66, which is bigger than 0.05. That means the sample means for two groups did not differ from each other. Let's do the same thing for the post-test scores. Go to Statistics, Means, again click Independent Samples t-test. Now I'm going to pick post-test scores instead of pre-test as a dependent variable. Click OK. And here are the results for the post-test scores. The mean for the e-learning group is higher than the mean for the non-e-learning group. Let's check again the p-value and the t-value. As you can see, now the p-value is smaller than 0.05, which means that the post-test scores are significantly different between two groups that are intervention group and the control group. I can conclude that the intervention or the e-learning program had a significant effect on people's computer scores. Now, let's talk about the dependent samples t-test. We will take the same example of e-learning, whereas the independent sample t-test is for comparing different groups, such as comparing the scores for experimental group and a control group. Dependent sample t-test is used to compare the scores for the same group, such as the pre-test score and the post-test score within the experimental condition, or the pre-test score and the post-test score within the control condition. We want to use the dependent t-test to test whether the experimental group improved their computer skills after the intervention in the post-test compared to the pre-test before the intervention. We would expect that the experimental group would have higher computer test scores in the post-test compared to the computer scores in the pre-test because of the e-learning program that they participated. This is how you calculate the t-value in a dependent sample t-test. Explained variability is calculated by average differences between the means of pretest scores and the means of post-test scores. Unexplained variability is calculated by standard error of differences between those two conditions. Now I will show you how to run a dependent sample t-test in using R. So here is my new data set. This time I only have the scores for the participants who participated in e-learning program, because I want to compare the pre-test and the post-test within the same group this time. To run a dependent sample t-test, you go to Statistics, Means, and go to Paired t-test. Here, you can pick pre-test as a first variable and post-test as a second variable. Click OK. And there you see the mean differences of minus 14.66 with a t-value and a p-value, just like the independent sample t-test. There you can see that the p-value is less than 0.05, which means that there were significant differences between the pre-test and the post-test scores of an experimental group. In this way, you can conclude that people who were in experimental condition who went through the e-learning program did improve their computer skills or the scores after the intervention compared to the before. That's it for today's lecture. Thank you for listening and goodbye.